Audio Jungle. Audio Jungle.
All right. Now, if you check the exam problem, like what type of question they are asking from the torsion. So I think this problem is what they had asked in 2020 from the torsion. Okay. So this is GATE 2020, and see this problem. It's simple only. What they had given, they mentioned a thin walled beam, a thin walled beam of constant thickness shown in the figure. Shown in the figure is subjected to a torque of 3.2 kilonewton meter if the shear stress or if the shear modulus is 25 gigapascal. The angle of twist they are asking, the angle of twist per unit length. So if you go for the solution of this problem, so as already we had discussed two types of solution, I mean two type of the theory, which is nothing but exact theory. With the help of the torsion formula you can calculate this angle of twist. Second was the approximation method, which is called Brad-Bathy theory, and with the help of both method you can do, but only one method we can choose here because like already you have practiced numerical based on both. Okay, so don't go for each and every problem by both method. Only one method you can choose. Which one is simple, you can take that and you can solve. If you check the diagram for C, because they have mentioned the as shown in figure, so the figure will be, this is the figure they have given to us. Okay, and if you check this dimension they have given us, 100 mm, and this dimension they have given us 400 mm. Thickness for this they have given to us, it is 2 mm. So you can check here, because as compared to other dimension that thickness is very small, so you can consider it's a thin wall section. Okay, even in the problem itself they have mentioned, but if suppose they have not given also, you can consider it, because if you check that thickness is what compared to 100 mm and 400 mm, that dimension is what very less. I mean thickness is very less. So now if you go for the solution of the this problem, so already in previous lecture you had seen that how to get the angle of twist for the thin section, and this thin section is what? This thin section is the closed thin section. So for the closed thin section you know the formula, that table I had given. With the help of that table you can get the result. So for the thin closed section, if you remind what was the polar moment of inertia and what was the cell area, based on that only you can solve this problem. So if you go for the thin wall closed, because this is the closed only, so if you use thin, you can say this is the thin wall closed section. Okay, thin wall closed section. So what was the formula of the polar moment of inertia? It was J. I already have given the table. Please go through the table. So it is nothing but, because it's a closed, so it is fully square divided by integration of ds by t means summation of the perimeter by thickness, and this is the formula one you have to use for this. And second formula what I had given for the angle of twist, so it was d theta by dz. If you check the table, d theta by dz, it is the angle of twist, okay, per unit length, and that formula I had given t by gj. If you solve this, okay, if you perform the value of j here in this formula, so you will get the result t upon, because torque they have given, so we keep that torque as it is 4a square, okay, 4a square g, and j value is nothing but, if you keep this, then it is ds by t will come here, so this will be the angle of twist, right? Now because everything they have given to us, so we have to perform the calculation. So they are asking angle of twist, so it is nothing but d theta by dz. If you check what is the d theta by dz, it is t upon 4 a square g integration of ds by t. I can give the numbering here for this problem: a, b, c, and d. So separately you can calculate j, otherwise you direct keep j here and finally you will get this formula. Better use this final formula because you will have to solve in very short of time. So what is the a? A is nothing but cell area. I already have mentioned a is nothing but cell area. So what is the area? Cell area, it is nothing but 100 into 400. So it is nothing but 4 into or 40 into 10 to the power 3, 10 to the power 3 mm square. See here, it is already considered approximation. They have taken already, it is thin, but sometimes internal and external dimension will be given to you and thickness is what given to you. So that time you need to find the median line and then you need to calculate the cell area. But here it is not required. Why? Because it is already considered as a thin cell. Okay, so approximation already they have taken, so directly you can calculate area. Hope you understood this. Now if you check, you keep the value here. So t is they have given to us how much? It is 3.2 kilonewton meter. Remember the unit, so it is 3.2 kilonewton, hence it is 10 to the power 3. It is meter, so convert into mm, so it is 10 to the power 3 again. 4 into area you have calculated in mm, it is 40 into 10 to the power 40 into 10 to the power 3 gigapascal you need to write in the mm. So if you 25 gigapascal, if you convert into mm, Newton per mm square, so it will be 20 into 25, right? So it should be 25. Please check the unit, and it should be master now in this, because now it's like conversion and all, there should not be any problem. So
area will be square, so
it is
10 to the power
yes,
3
yes,
is all.
yes. Please make all. Every time I'm making mistake by this, I don't know why. Anyway, so this will be the giga pascal. Now this integration ds by t. So integration is what? Summation for all sides. So it is ab. So every side, if you check, it is the constant area. I think constant thickness they have given. So t is the common. This dimension you need to take: a to b, b to c, c to d, and d to a. So a and b and c and d will be same. Similarly, b and c and d and a will be same. Or for one time, for your just acknowledgement, ab is what? Let me check. Ab is nothing but 400. So I will write 400 divided by 2 ds by t plus this side, it is nothing but side is 100. So it is 100 by 2 plus again 400 by 2 plus again it is 100 by 2. So if you perform this calculation, so you will get your result. This is the fill in the blank problem, and in bracket they have given the unit radian per meter. So whatever value you will calculate here, because everything you have kept here in millimeter, so whatever the value you will get in millimeter, convert that into radian per meter. Okay, so if you directly, if you calculate what value you will get in radian per mm, so it is,
And so this will be in
yes, 1 into 10 power minus 5, it's radian per mm, right? So if you convert into radian per meter, so what value you will get? It is 10 power minus 3, so it may be 0.01 radian per meter. Can you say like this?
Yes, sir.
Right. So this will be your answer. Okay. This was question they had asked in GATE. Now we'll go for another question. So this is also they had asked in GATE aerospace, and you check the year. Okay. They had asked, this is the C channel problem, so this is necessary because for the C channel we had discussed many times. So need to solve this. So check. The question is second question. They mention the channel section. The channel section means they are talking about the C channel, channel section of uniform thickness. Uniform thickness means constant thickness. Uniform thickness 2 mm, 2 mm shown in figure. Shown in the figure is subjected to a torque of 10 Newton meter, okay, with G is equal to, they have given again 25 gigapascal. The twist per unit length. They are asking the twist per unit length in radian per meter dot is. Okay, this is the question, and section they have given to us. This is the section. This is what open channel. This is what open channel. Dimension for the section they have given here. It is what 600 mm. 600 mm. Okay, this is the question. Simple. This is what this problem is what thin, but it's open. So always remember, previous problem we had solved, that was thin but closed section. Okay, this was the thin and closed section. Thin and closed section, but now this problem simultaneously they had asked solution. If you go, and this problem is what basically thin wall but open section. So check the table. In table I had given how to calculate J. So J was number one formula J. It was B T cube by 3. Check, and it is the summation. Okay, you can write it is the summation like this, or integration also you can take, it's your choice. And second, they are asking d theta by dz. So if you know the value of J, then directly you can write T Gj. Problem will be solved. Okay, so how to get btq by 3, btq by 3, that is the polar moment of inertia, and it's a summation. So thickness should be given to you here. Thickness, they had given thickness 2 mm here, right? This thickness everywhere because it's a constant for all the section, it is constant. So you can say this is what A, B, C and D. How many sections you have? A to B, B to C and C to D. So you need to calculate. You can say btq by 3 for AB. You can say btq by 3 for CD, btq by 3 for BC and CD. That's all. So if you do that, then your problem will be solved. So both type of problem they had asked, I mean closed and open. So how to do this? You just start solving this. So btq by 3 for AB and BC and CD you need to calculate directly. T is given, G is given. Now keep in the formula, so you will get the value. Okay. So start solving this solution. So we need to calculate J. For AB section, if you check that width they have given 200. So I can say, see, this and this side is what same. So I can say it's 2 times of BTQ by 3 for the flange plus BTQ by 3 for wave, you will get the result in this way easily. Okay, so check it now. So here it's nothing but 2 into b for the flange. What is the b? It's 300. So 300 into thickness is nothing but 2, so 2 cube divided by 3 plus for the wave, what is the width? You can say it's a 600. It's a 600 into thickness is constant, so 2 mm. Oh, actually today I'm in hurry. B cube, okay, divide by 3, this portion is what? No, fine. So if you calculate this value, so J you are getting 3200 mm to power 4. Am I right? So,
Yes, sir.
okay. So now if you go for the calculation of the torque, so torque angle of twist, so it is d theta by dz is equal to d. So now if you go for the angle of twist, what they had asked here, twist per unit length, but it is radian per meter, so we'll convert it later. Meter we can convert it. So d theta by dz will be t divided by g j. What is the t they have given to us? T is nothing but it's they have not given 10 Newton meter. 10 Newton meter. So 10 into Newton into meter is what? Convert into mm. So and g you can write in Newton per mm square. So it's a 25 because it's a giga. So 25 into 10 power 3 you may get, and j you have 3200 mm. Now get this result in radian per mm first.
Sir, in radian per mm, it will be 1.25 into 10 to the power minus 4.
1.25 into 10 power minus
4.
Okay, but in exam they are asking radian per meter. Convert it
So
into
it
meter.
will be 0.125
0.125
radian per meter.
Yes, this will be your answer. So this is the second kind of question. I mean, open